Medic, and in this video we're going to talk about discrete random variables, and we're going to do that using the activity titled How Many Children Are in Your Family? So we have three learning targets that we'd like to address here. The first one is to use what's called a probability distribution of a discrete random variable to calculate the probability of an event. The second one is to make a histogram to display the probability distribution and then be able to describe the shape of the histogram. And then the third learning target is to calculate and interpret the mean, also known as the expected value of a discrete random variable. So let's take a look at the activity. The activity is titled, How Many Children Are in Your Family? And so you can see it says here, count up the number of children in your family, including yourself. Be sure to include all your stepbrothers, stepsisters, half-brothers, half-sisters. Let X equal the number of children. Suppose that we choose someone from class at random. Now, we need a data set for you all to be able to work through this activity. So I'm going to use some data from one of my classes. So why don't you just go ahead and record this. There were 30 students in this particular class. And of those 30 students, 3 of them were only child. So we're going to put the probability in there as 3 out of 30 because there were 30 students total. For 2, there were 7 out of 30. For 3, there was 9 out of 30. For 4, there was 5 out of the 30. For 5, there was 3 out of 30. For 6, there was 2 out of the 30. There was nobody who had 7 in their family. And then 1 student who had 8 siblings total. So those are the values that you can use in order to work your way through the activity. You have everything that you need in order to work through question number 7 here. So go ahead and try. Those problems on your own, and then you can come back to the video here to check your answers. So go ahead and pause the video now. So let's see how you did in the activity. For question number 1, we had to determine whether or not this is a valid probability model. So you had to think back to some previous learning in terms of probability to know what it means to be a valid probability model. And there's 2 things that you need to check there. The first thing that you need to check is that all of the probabilities have to be between 0 and 1. And sure enough, they are. And then the second thing here is that they have to add up to 1. So if you add up all the probabilities there, it should be 30 out of 30, which is in fact 1. So we do have a valid probability model. Now for number 2, the question is 5.7167 a possible value for X? And of course not, because X represents the number of children in the family, and we certainly can have 5 children or 6 children, but we can't have a part of a child. And so what that's telling us is that this random variable X is what's called a discrete random variable. So a discrete random variable can only take on whole number values. It can't take on decimal values. Here because we can't have part of a child. Now, later on, you are going to learn about what's called a continuous random variable. And for a continuous random variable, you can have all of the decimal values. And so typically the difference is that for discrete random variables, most often you are counting something, whereas continuous random variables, you are measuring something. So question number 3, you had to take that probability distribution and turn it into a histogram. So you're going to want to check to make sure that on the x-axis you have labeled that as the number of children. And for the y-axis, that's where we're graphing the probability. And you can see we have the probabilities graphed for each one of the values for the number of children. And then we had to describe the shape, hoping that you said that this is skewed to the right, because you have that distribution being drawn out to the right with maybe even a possible outlier there at 8. I am going to add one small thing to the description of the shape here. I'm going to add the fact that there is a single peak at 3. Just giving a little bit more detail about the shape. Okay, let's move to question number 4. The probability that x is greater than or equal to 3. Well, that is the probability that a randomly selected student has 3 or more children in their family. So when we say 3 or more, that's 3 or 4 or 5 or 6 or 7 or 8. So up here, we would say 3 or 4 or 5 or 6 or 7 or 8. We could add all of those probabilities together, and sure enough, you're going to get an answer of 20 out of 30 there. So let's move to question number 5, which says, describe in words what the probability of x greater than 3 is. Well, for this one, we know that this is the probability a randomly selected student has more than 3. So notice the difference between question number 4 and number 5. In number 4, we want 3 or more. In number 5, we want more than 3, which does not include the possibility of 3. So if we go back up here, more than 3 is going to be 4, 5, 6, 7, or 8. So you would add all of those up, and that should give you your answer of 11 out of 30. All right, number 6 says find the average of the x values. Okay, for this one, all we were doing here was we were taking all of the x values that are listed and just finding the average of those. So the numbers 1 through 8, let's just find the average of those. So you can see here in number 6 that we've just added up the numbers 1 through 8 and then divided by the number of numbers. And so we're getting a value of 4.5. So some people might think that that gives us the average of the x values, or the average number of children in each one of the families for these 30 students. But then question 7 says, does this value truly tell us the average number of children? If yes, explain. If no, why not? Well, when you look back at the probability distribution here, you can see that we really shouldn't be weighting each of the numbers 1 through 8 the same, because you can see very clearly here, 3 should be weighted a lot more than, say, 8 or 7, of course, because there aren't any. And so somehow we need to allow for the probabilities to be included in our calculation for the average, and 3 should get a lot more weight than other values. So here's how we actually would calculate the average value for x. We would take each one of the x values. So let's start with our x value of 1. And the way that we're going to weight it is according to its probability. So we would multiply this by 3 out of 30. Plus we take the next x value, which is 2, and then weight it according to its probability, in this case 7 out of 30. Now here comes 3, which should be weighted the most, and will be because the probability is the greatest for 3. And so we're just going to go through and take each value multiplied by its probability, and we're going to add all of those up. Now 7 we don't even really need to include because it has 0 probability, so if you multiply by 0, it's going to give you 0. But if you wanted to show the work, that is going to end up being 0. And then we have our 8 times 1 out of 30. And if you were to put that into your calculator, I will tell you that that average value comes out as 3.3. Okay, so the answer here should be, for the average of x, 3.3. Now let's write out a formula for what we just did there in order to calculate the average of the x value. So I'm going to put this over here in the margin, and the formula that we used here was to get the mean of x. We just took the sum of each one of the x values, which I'll write as x sub I, multiplied by its probability, which is how we were weighting that. Now, very important to notice in this formula is that even though we're calculating an average, we do not divide by the number of numbers at the end of the calculation, because we've already taken care of that by using the probability for each one of the possible x values. Now, the other thing that's important here is that, yes, this is called the mean of x, but it is also sometimes called the expected value. And so if we are randomly choosing a student from this class, the expected value, or the mean number of children, is 3.3. So let's go ahead and summarize our learning in the important ideas. Real quick, before we get to the important ideas, I wanted to make sure you know how to calculate the expected value, or the mean, using the applet as well as using your calculator. So we're going to start with the applet here, which is available at staplet.com. Just make sure you're clicking on the Discrete Random Variables applet. And you can see here I've input the variable name and all of the values for the number of children within the families. And then I've also input all the probabilities here. And all I have to do here is click Begin Analysis. And here's what we get. We do get a histogram of the discrete random variable, which we already saw in the activity there. But then on the bottom here, I get my summary statistics. And so this is the mean, or the expected value, that we just calculated by hand of 3.3. In a later lesson, we'll take you through the calculation of the standard deviation. Now let's make sure you know how to do this on the calculator. So go ahead and grab your calculators and let's take a look. On the calculator, the first thing that we need to do is to get the data into lists. So if you hit Stat and then Enter for Edit, you're going to want to put all of your x values in list 1. So you'll see here I've input the number of children, 1 through 8, in list 1. And then in list 2 is where you're going to put the probability of each one of those x values here. And so these are all converted to a decimal, but we wrote those out of 30 within the activity. So we have our x values, and then we have the probability of each one of those x values. Then you're going to hit Stat and go over to Calculate. And what we want here is one variable statistics. It's the first one there. And by default, it should be looking at list 1. Now, one of the most common mistakes that students make is they leave that as list 1. They leave the frequency list as blank, and they just go straight down to calculate. And what the calculator is going to do is only look at list 1. And you'll see here that it gives you an average of 4.5, which we know is the incorrect average. That's when they just average all of the x values without taking into account the probability of each one of those x values. So here's the correct way to do it. Go back to Stat, go over to Calculate, and you want one variable statistics, but you have to put in a frequency list, which is where you're going to input list 2, where you have your probabilities stored. And so now the calculator knows that each one of those x values are not weighted equally. So if we hit Calculate, this is going to give us the correct mean, or expected value, of 3.3. Also going to give you the standard deviation here, which you'll learn more about in the next lesson. So now let's jump back to the important ideas. So for the important ideas here, let's go back to the learning targets from the beginning of the lesson. The first learning target was about understanding a probability distribution and then using it to calculate probabilities of certain events. So let's just list this as learning target number 1. And we're going to show the idea of a probability distribution. So probability distribution always has 2 parts to it. The first part is to know all of the possible x values. So you'd have your possible x values. And then the other thing that's important is that you need to know the probability of each one of those x values. So generally you're going to see this presented to you in some sort of a table format where you have each one of the x values and their probabilities. And it's important to note here that you will only be given a probability distribution when you have a discrete random variable. So let's write out the definition of a discrete random variable. Takes a fixed set of values with gaps between values. So for the number of children in a family, we know that you can have 5 children or 6 children, but there's a gap, a jump from 5 to 6, because you can't have some decimal version for number of children there. And so that's what we call a discrete random variable. Later on, you'll learn about a continuous random variable where you can have all of the values in between the integer values. All right, the second learning target is to make a histogram and then be able to describe the shape based on the histogram. So learning target number 2 is just a histogram of the probability distribution. And so we made one of these here. Let's draw an X and Y axis. Of course, on the X axis, you have whatever your values are that are being measured by the random variable X. And then on the Y axis, you have your probabilities. And then you draw in your histogram. And then hopefully, based on the histogram that you see, you can describe the shape, much like we did way back earlier in the year when we would describe a distribution. All right, and then the third learning target here is to calculate and interpret the mean or the expected value of a discrete random variable. So let's just list this as learning target number 3, which is the mean, also known as the expected value. And we did come up with a formula for the expected value for a discrete random variable. So it's the mean of X is equal to the sum of each individual X value multiplied by its probability. And one thing to note here is that if you get a decimal value, that is certainly okay to have a decimal value when we're talking about expected value. So now that you have the important ideas, let's see if you can apply your learning in a new context here in the Check Your Understanding. So go ahead and try these problems on your own, and then you can come back here to check your answers. So go ahead and pause the video now. Let's see how you did on the check your understanding problems. For part A, we had to first write out some probability notation to describe the event the student has seen 3 Home Alone movies, which is represented here as the probability of X equal to 3. Now, because that value wasn't given in the table, we had to figure that out, but we know we need a valid probability distribution, which means all of those probabilities will have to add up to 1. So we can just simply add up all the values that we have there, subtract from 1, and that'll give us the probability that X equals 3 as 0.08. For part B, we had to take the probability notation and turn it into words. This time, it's the probability that a randomly selected student has seen at least 3 Home Alone movies. You could say 3 or more Home Alone movies. That would be the same thing. And then we had to calculate that probability. And if it's at least 3, then we need the probability that X is 3, plus the probability that X is 4, plus the probability that X is 5, which is going to give us 0.11. For part C, you just have to take that probability distribution and turn it into a histogram and check to make sure that you've labeled your x-axis and your y-axis, and then also that you have described the shape of this distribution, which is definitely skewed to the right with a single peak at 1 movie. And then the last question, calculate and interpret the expected value or the mean here. So we had to take each one of the X values and multiply them by their respective probabilities to give us a final answer of 1.43. Now notice we are not taking that answer and then dividing by some other number. We've already taken care of that by using the probabilities as weights. So the interpretation of this is if many students are randomly selected, the average number of Home Alone movies they have seen is about 1.43 movies. So this concludes the video for discrete random variables. Thanks for watching.